This question is from GATE Mechanical Engineering of 2014. This is question number 49 of set 3. The question is, a diesel engine has a compression ratio of 17 and cutoff take place at 10% of the stroke. Assuming ratio of specific heat gamma as 1.4, the air standard efficiency is, so we need to calculate the air standard efficiency in percentage. Let's see the diesel cycle. So this figure represents the PV diagram of air standard diesel cycle. So process 1 to 2 is isentropic compression process. Process 2 to 3 is constant pressure heat addition, that is combustion process. So heat is added in this process, and 3 to 4 is isentropic expansion process, and 4 to 1 is heat rejection process. Now we need to find the air standard efficiency. Let's say eta T be the air standard efficiency of the diesel cycle, which is given by 1 minus 1 upon gamma multiplied by the compression ratio to the power of gamma minus 1 whole multiplied by the cutoff ratio to the power of gamma minus 1 divided by cutoff ratio minus 1. Now according to this figure, the cutoff ratio, which is represented by pi here, is equal to V3 by V2, and the compression ratio R is equal to V1 by V2, which in the problem is 17. Okay. Now we know that cutoff take place in the combustion process. So according to the problem, it's given that cutoff take place at 10% of the stroke. So full stroke is from 1 to 2. So this will be V1 minus V2. This is the full stroke. And in the problem, it is given that 10% of the full stroke. So we multiply it by 10 by 100. And that is equal to the cutoff. So that is V3 minus V2. Okay. Now from here, we can write V3 by V2 minus 1 is equal to, so this is 0.1 times V1 by V2 minus 1. Okay. So this can also be written as, now V3 by V2, we are saying that this is the cutoff ratio pi. Okay, we'll substitute it later. So this will be equal to 1 plus 0.1, and V1 by V2, that is the compression ratio is 17 minus 1. So from here we get V3 by V2, that is the cutoff ratio pi, is equal to 2.6. Okay, and it's also given that the ratio of specific heat capacity gamma is 1.4. Now we have all the values to find the air standard efficiency of diesel cycle. Okay, so we have the cutoff ratio pi, that is 2.6, the compression ratio R, which is 17, and gamma, which is 1.4. Let's substitute all these values in this equation and find the answer. Therefore, the air standard efficiency eta D of diesel cycle will be 1 minus 1 upon gamma, which is 1.4, multiplied by the compression ratio, that is 17 to the power of 1.4 minus 1, that is 0.4, multiplied by the cutoff ratio, that is 2.6 to the power of gamma, which is 1.4 minus 1, divided by 2.6 minus 1. Okay, so from here, using digital calculator, we can get the value 0.596, or in percentage, we can write the efficiency of diesel cycle is 59.6%. Okay, therefore, let's fill in the blank here. The air standard efficiency is 59.6 in percentage. For more information on diesel cycle, you can refer to the NPTEL course lecture number 60, Diesel Cycle, on Concepts of Thermodynamics by Professor Suman Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.